We're going to be analyzing these two reactions that have a benzene ring with multiple substituents. And we're trying to perform a bromination. In both cases, we need to predict what are the products, what is the products, to see what happens. So when you have more than one substituent, so multiple substituents, we need to analyze what type of substituents we have and what is going to be determining the orientation for the next synthesis. Next synthesis here, I'm trying to install a bromine group. So, but where? So let's go analyze this two constituents. Here you have a nitro group. So deactivating. Remember that nitrobenzene is much less reactive than benzene, reacts slower towards electrophilic aromatic substitution. Not only deactivating, it's meta-directing. Now, here you have an alkyl group. And alkyl groups are activating and ortho-para-directing. So when you analyze a substrate like that and you have an activating and a deactivating group, the group that's going to rule, say, determine what is the, where is the substitution is the activating. So again, it's like the activator is going to win here. So the substitution is going to be determined by the metal group. Remember, that's activating. The nitro is deactivating. Determining that is crucial. So next, we have already determined then that this substitution on the metal group being activating is going to determine the product. Next, this is directing ortho-para. So ortho to the metal group and para. Para is occupied, so what is my product? So bromine is going to go where the arrows are. So let's do this. So I have my metal. Bromine is going to be here. And nitro. And I only have that one product. The other position is identical, right? So I have one product. So now let's analyze the next reaction. What type of groups we have and how they are directing. So here I have a metoxic group. That's activator and is stronger than an alkyl group. So it's activating, and all activating groups are ortho-para directing. Now this is alkyl, an alkyl group, so a metal. It's also activating ortho-para directing. So how do we determine where is the substitution going to occur? So here, the metoxic group is a stronger activator than the metal group. So a stronger activating group is the one that is going to be determining where the substitution is going to happen. So let's see where then. So we have determined that the metoxy is a stronger activator. So this is determining where the reaction is going to happen. And it is ortho-para to the metoxic group. So here are the ortho positions, and the para is occupied. So I have one product, and that is with the bromine ortho to the metoxy group. Okay, so that's how we determine that. So here we have example with the activating, two activating groups. So I'm going to do one more scenario to that. And that is, what if I have the following situation? I'm going to do chlorine here, and I'm going to do nitro. Okay. So now, say that I'm trying to do the same, and the idea is here that we analyze what these groups are, activating, deactivating, and where is a product is going to form. So I'm going to divide the screen like that. Okay, so chlorine. Halides are deactivating, but they are ortho-para directing. So I'm going to write it down. Remember that halides are the exception here. So deactivating, but ortho-para directing. And this I'll say the weakest deactivators. Nitro group is also deactivating, but much stronger. So deactivating, and it is meta-directing. All right, so when you have two deactivating groups, now the next substitution is going to happen. So it's going to be determined, say, by the weakest deactivator. So of these two, the chlorine is weaker deactivator group. So it's going to be, since chlorine is the activator but it directs orthopara, so it's going to be here. And notice that anyways, by the location of the nitro group, it is the most activated position relative to the nitrogen is the meta, which actually coincides with that. But again, when you have two deactivating groups, the group that is going to determine where the synthesis is going to go is the weakest deactivating group. So my product now is going to be where the arrows are here. So ortho to the chlorine. And this reaction will, with two deactivating group, is likely to have a low yield and not happen fast. So the reacting is slower than benzene. And this is actually much better, two activating groups. And let's say that's mother, if we were talking about rates. So, but that's how you analyze. So remember, multiple substituents determine whether they are activators, deactivators, and where they orient. Activating, deactivating, then the activating group is the one that is going to be determining the location. If you have two activators, then the strongest activator is the one that's going to be determining where the substitution goes. And if you have two, the activating group is the weakest. The activating group that is going to determine the next substitution.